I just want to have a short sharing regarding a new features, not really a name of features, kind of an implementation for to strengthen the security in our web application. Right? So I hope you are familiar with this term, but even if you are not familiar, I hope that this talk could be useful for you. So the topic of this talk is mainly focusing on Passkeys, which is recently promoted by several big organizations, including Google and Apple. And Microsoft is even put some effort in the latest release of their Windows system. And we will go through the introduction of the Passkey. What is it? How does it work? And then how can we implement Passkey in real application? And then yeah, we need to consider the answering the question. So would it be with the introduction of Passkey? Would it be the end of passwords in zero? So the common issue nowadays with password is that it's an internet era. Right? We have a lot of the online services, and the common way for authenticating a user is based on their credential, including username or email, and in combination with password. And this is a very headache to remember of the password we have on the multiple services. Many users have a common approach in naming their password, similarly reusing their password or only change certain character in their password, so it is easier for them to manage. And the trade-off it does it expose all the credential for the attacker. Right? They can have many ways to trick the user to review or steal their password. There are some ways to strengthen that, namely using the password manager like 1Password, Bitwarden, or other, right? LastPass, or even some company they impose the security protocol to inform the user to use two-factor authentication to ensure that even if the attacker they gain access to the user password, there's still another step of restriction before they can access the service. But all that are not that user friendly. Right? They are not. I'm sorry, so why there's this term? So they are not user friendly, and they are not really secure. Report show that they are only around less than 30% of all the user on the internet that use two-factor authentication. So most of them relying on password only, and this is the common issue all of us are aware of. So with the effort joined by multiple organizations to find another way to still authenticating the user, but in a more secure way. So first, they come up with a specification named web authentication. This is just a abbreviation. So basically, it is a web authentication. You can find the link on Mozilla. Basically, it is a JavaScript API consists of several API for authentication. So how does it work? Web authentication work in a way that it allows the web application to register and authenticate the user without using password, meaning the passwordless. So basically it works like this. When using web authentication, the server will when a user registers their account on a website, so they don't use password. There will be a key pair, including a public key and private key generated. And the public key is kept on the web server, private key kept on the user device. And whenever the user needs to authenticate with the web service, they will use their private key to sign a challenge, and it will be validated by the web server. So if it matches, the server will authenticate the user. The benefit is that the web server, it doesn't keep any credential on the user compared to password. Usually we need to keep the hash of the password, right? But in web authentication, the server only keep the public key. I think you are familiar with the cryptographic when using private and public key, right? The concept is quite similar. The server only keep the public key, and the private keys that lie on the server device, so it is secure. The user don't even need to remember that. But there's a big drawback in web authentication is that the private key lying on a user device. So it means if the user has multiple devices, they need to generate like several key pair for each of their device. It's not that user friendly. So based on that, there's a group of like, several big organizations, including Google, Microsoft, Apple, and recently Mozilla. They found the FIDO Alliance, and they developed a new how do I say, not really protocol, but yeah, let's stick with to the term. I couldn't find a better word. So they developed a new spec named Passkeys. Passkeys is still based on web authentication with one major change is that with Passkeys, the private key will be synchronized to the cloud, so it can share between all the user devices, so it improves the user experience. And the strength of Passkeys, including like because it's based on web authentication, so it's friendly to user. When they register an account, they don't need to think about the password. The registration process is very simple and straightforward. And you will see quickly in a short example I will show shortly. And it's secure because as mentioned, the user don't need to remember the password. They don't need to reuse the password. Authentication based on the key pair, right? And the server, the web server, it just keep the public key. So even in case of the database leak, the attacker can't do anything. They can just have the public key, so they can access to the web based on the behalf of the user. And it's scalable. Scalable means with Passkey, you will see quickly the private key is synchronized to the cloud and shared between all the user devices. So let's say if you need to log into a new device on TV or any new device, the login process is very simple. Let's go to an example. So let's look at an example. Give me 1 second. So this is a demo created by another company for demonstrating a Passkey. As you can look on the screen, this is a registration form. When the user comes, this is the simplest form. When they need to register an account, they just need to input their username and click on register. Then the system, in this case a browser, will ask them where they want to save their Passkey. They can save on their Chrome browser and will be synchronized between all their profiles. So it means that they can use the same Chrome profile anywhere else to log in, or they can save to iCloud keychain. In this case, I will say in iCloud keychain, so to demonstrate that we can log in on other devices and other browsers. And then the user will be requested by the OS to authenticate themselves with the keychains. So because the authentication is needed to ensure that the user has access to the keychains to store the passkey, to store the private key. And then the user is successfully registered. So to simplify that process, to reduce the noise, it will work like this. The user want to register to a website, so the website, they will click on a button. The website will talk to the server that I need to create an account. Then the server will say send me a public key. So on the client side, the browser, it will generate a key pair including a private key and public key, and there are some other including the channel. I will go more into detail, but basically the client will generate a key pair, and the client send the public key to the server to keep on their server side, and then the registration process completed. Going a bit into more detail, so this is a bit more technical detail. So the user come to the website to register the account, they enter our email or password, and the server will send back a challenge. A challenge simply means a long random string So the give me one sec. And then on the client side, it will generate a key pair and sign the challenge, and the result is a public key, an authenticated ID, sending back to the server. The server will validate that credential, saving the public key and authenticate the user. And after that, the user can log in on the same site like this. If you remember, last time when I registered an account, I tried it on Chrome, right? And now I can log in on another browser or even another device. Now, in this example, I'm using Safari to log in. And I already went a step further to register like several accounts. Right? All of them stored on the keychain. So when the user log in, and the system will detect all the passkey available for this specific website, and it will ask the user which one they want to choose to log in. They must authenticate themselves using a biometric, for example, fingerprint or Face ID. In case if you log in to this website on your iPhone, the same passkey is synced, and you can authenticate yourself using Face ID and choose the right account to log in. And then the user logging into the website. So from the user point of view, the process for registration and authentication is very simple and seamless. It's way similar comparing to the old day of the password when you need to think about complex password. So the process will look like this. The client asking sending a request to the server saying, hey, I want to sign in. The server say will send back a challenge asking, hey, sign this data so I can validate. The client this time we will pull down the private key from the keychain inside the challenge and sending back to the server. The server validating that and check if it match to any user they are on their system, and let the user log in. This is a real world example. The one demonstrated above is just a simple website, but Passkeys actually now commonly supported by many major services, including GitHub. Yeah, I think we are developers, we like GitHub, right? So GitHub like already support Passkeys. Beside that, Google and some other. So this is a real world example. So when logging in, I can either entering my password or using a passkey. So this is the flow. The user enter their credential, could be the username or email. The server create a challenge asking the server to asking the client to sign. The client, I mean in this case the client is the web browser. It will like asking the OS to authenticate the user by using fingerprint or Face ID to access the keychain, and then the credential like taken out from the keychain to sign the challenge returned by the server and submit to the server to validate and log the user in. So that's how Passkey work, right? And someday we will need to add that to our real application. So which solution we can try? We look at several options, and there are two major ones. The first one is a web authentication. Web auth Ruby basically is an abbreviation for web authentication. So it is an implementation for a web auth in Ruby. At the server side, it do all the responsibility that the server need to do. For instance, creating the challenge, validating the passkey, and managing the passkey. Right? But this one is focused solely on web auth. So if you want to add that to your application, you can only have a web auth I'm sorry, you can only have Passkeys as one of the only way to authenticate your user. But I don't think it's a wise choice for a real application, because device is a common way for implement authentication in any real app, right? So there's another gem named device Passkeys. It is a wrapper for web authentication, but it works with device. I went with this approach to try out, to quickly try it as in a demo to see how it works. By using this with device, we can still have all the benefit of device. It means that we can still allow the user to generate to register an account using the traditional approach using username and password, right? Or we can also allow them to authenticate themselves using Passkey. So it's an extra fit on device. So this gem is about. This is this gem is still at a very early version. The latest release is 0.3.0.3, so it's still basically the alpha version. The major version, the first stable version, has not been released just yet, and it's very because it's still alpha, so it's very lightweight and non-configurable. The documentation is also very limited, and it only does what it has to do. Basically implementing Passkeys. If you want to extra feature, no, it's not the right choice at this time. So here are the features it's provide. So it's provided the three main endpoints for the server, including Passkey registration or sign-in, creating the challenge to return to the client. Because on the client, the browser or mobile device, they need to get the challenge from the browser, so they can start the flow on their side, authenticate the user, accessing keychain and more. And the last endpoint is to access the Passkey data submitted by the client and validating that. This is the simple demo of a real app built on that gem. We just integrate following the requirement, integrating that, and we have a plug and play passwordless solution for our web application. Very simple. And and it also has an extra feature for allowing the user to manage to list their Passkey, manage their Passkey, add or remove one. You just see the QR code. It is used for the case that if the user log in for a new device, let's say on TV, and on TV they don't have access to keychain, right? So we can use a device like mobile phone who has access to that, scan the QR code, authenticating on a mobile, and then the user on the TV will be logging in. And give me one sec. So what are included in this gem? So there is a device module we need to include into our model. It implements a device method to authenticate the user. It also provides several controller concerns for authenticating, generating the challenge. This new challenge function is responsible for generating a JSON response to return to the client, and the client needs to use that to start the flow on the device side. And there are several other controller concerns as listed here for managing the Passkey, logging in the user, or registering a Passkey. So what we need to do to set up this gem in a real application? First, we need to add a device module to our user, to our device model. The module implement the Passkey authenticatable to let the name say it all, to let it work with the Passkey. And on the controller side, we also need to add more concern. Those concern will have us to have the endpoint listed above. Here we will also on the root, we need to define the extra root for Passkey, so the client can work with that. But this gem, as you just see, this one is only responsible for all the work on the server side. generating the challenge, validating the passkey, authenticating user. But on the client side, as you can see, there are some steps needed. Right? For example, asking the user to authenticating, fetching the private key from the keychain. There, for this UI, we need to use another gem named Web Authentication JSON. So it implements all the flow we need on the client side based on the Web Authentication API. And after trying that, I see some limitation. First, this library relies heavily on the two other gems, Warden, because technically it is just a wrapper for Web Authentication Ruby, and it also integrate with device, so it also need some authentication strategy. So in this case, it needs to relying on other library, Warden Web Authentication and Warden Authentication Ruby. So it means there are more code that varies with underneath this gem. So a lot more complex, and customization is quite hard because we need to override the signature method. So in case your app needs a lot of customization, this one is not the right choice as of now, due to their support and implementation. And last but not least, because as mentioned, this is at a very early version, the beta one, the alpha one. So the document is very concise, not very detailed. So in case you got stuck, there are not much help. So if you really need to use an element passkey, so a better choice could be using the Web Authentication Ruby. There are more work for you to do, but you have more control, you have more support. So back to the question. So do I think this will be the end for password? Well, technically, yeah, it's very secure, right? So, because unless our device is locked, then the user, we can always access the account, and it's very hard for any phishing or social engineering attacking. But it's still there are some limitation for passkey because it really depends on the support on the by the device. Now only Safari, Chrome, and Edge support passkey natively. Firefox is still under development and only released in the next 2 months. Windows 11 only has a partial support, and we need to wait for the next release. So rolling out this feature as the only option for user to log in is not a safe choice. Right? We will need to wait a bit longer, but I think it's worth it under our attention. So when is like widely supported, it is a safer way for both our web application and for the user. That's all for my sharing. Thank you for your time, and yeah, you have any question, I will try to clarify.
So then what if the user lose their devices, just as we said?
If they lose their devices, yeah, it's very hard. Nowadays with passkey, it will be less problem because let's say if you choose a passkey provider like Google Chrome profile or even 1Password, they also updated themselves to be a passkey provider, so they can store your private key and sync across all the device. So if you lost one device, you can still use the other device to regain access because you can still access to 1Password or keychain. But if you lost all your device, then yeah, you are doomed because there's no other way to recovering that unless the service you are using 1Password. If they have some account recovery process, but basically you are locked into that.
But, for the iPhone example,
yeah.
The user don't have to lose the device. I mean, what if they lose the iCloud account because the keychain is stored in the
yeah.
iCloud account?
Yeah, in that case, you lost access. Yeah.
Still like lost.
Yeah, you still lost access to your account because I think there's some motivation for these big tech to push for Passkeys because they will make us like locked down to their ecosystem, right? For me, I definitely like to store everything on keychain because I can access on all my devices, but it also make it very hard to switch to another ecosystem because let's say if I want to switch for Google, then I need to somehow to recreate the passkey for all my account. So yeah, if you want to use Passkeys, it's better to choose a cross-platform provider like 1Password or LastPass or yeah maybe even Google Chrome, so you can access everywhere. Any other questions?
So
Yeah.
Before client accept to the passkey, they will have to authenticate.
Yeah.
before accept. So is it up to the device and so like if you MacBook you can use the fingerprint biometric.
Yeah.
Any other solution authentication job device or
Yeah, it depends on web authentication API relying on the physical the hardware built-in on the device. So on Windows we use a Windows Hello. Windows Hello can authenticate you using a PIN, PIN, right, or camera or fingerprint. On MacBook you use a fingerprint. On iPhone you use Face ID. So basically the biometric method depend on the device.
yes, so if they have access to your device they can log in.
Yeah, so I think the risk is the same. We can say in another way that if you reveal your password, the other can log in, right? So if we say can look at it at that way, using biometric is how do I say, is more secure, right? Only you have access to your fingerprint, right? But password you can somehow, if you write down, someone can look at it and they can access.
They
Again.
they can cut your fingers.
Yeah, yeah. Any other question? Otherwise, I think to cut the time, I think yeah, let's wrap it up and put time, right?
Yeah, have some food.
Let's grab some food and we can discuss further outside.
Okay.
Yeah.
Okay,
Thank you. Thank you. Let's go out and grab some food.